Dirt and air and water. We're talking about HVAC systems, chill water loops, condenser water loops, hot water loops. How does dirt and air get into these loops? And then we'll talk about like what's the problem with that, and then how do we get rid of it? Hi, I'm Tony Mormino with Insight Partners, here with Jamie Ambo, the regional manager for Spirotherm, and we're going to talk about air and dirt in the water, why it's in there, how to get it out, and what are the benefits. So how are you doing today, Jamie?
Doing well, Tony. Yourself?
I'm doing great. So how does dirt, when we say dirt, what are we talking about, first of all?
I mean, it can be dirt, it can be rust, it all depends. I mean, the word is interchangeable for me, but to really differentiate it, I mean, it is rust, is mainly what we see. Dirt is purely, it is dirt. So if there's an underground leak somewhere or whatnot that you just can't figure out where it is, but you have sand in your system, so that is dirt, like dirt 101. So, but rust is made from air, water, and, oxygen, water and steel basically mixed together, and you get rust or mud or sludge or whatever you want to call it. So.
Okay, so that's a good point. You bring up air. So one of the reasons we don't want air in our systems, well, there's several reasons, but one of the reasons is it causes rust, right?
Exactly. I mean, everything is basically made with steel pipes these days. They're starting to turn the corner a little bit on that, but retrofit is always going to be a steel pipe. So you do retrofit or even new construction still with steel pipes. So you want to basically keep everything lasting longer. So, and that's really why we want to get the air. The air is really the problem because it causes items to rust later on. So it may not be right away, but eventually we will physically see what's happening. Whereas if it's just air in the system, you might just see, for instance, my 700-ton chiller is only giving me 650-ton output, and I don't know why.
Right, so this is kind of a loaded question, and I think most people understand is rust bad when it's in the system, right?
Right. I mean, same thing. Between rust, mud, or air, they're all an amazing insulator. And we don't want to insulate the inside of the pipe. We technically all day long insulate the outside of the pipe, because that's where your heat transfer source is. But on the inside, I mean, we want that water as cold as it can be, or as hot as it can be technically, and we don't want to lose it by storing it in mud or rust somewhere, or basically not even having like flow, so to speak, going through a system. So, because it's kind of like the human body and your blood veins and your arteries and whatnot. If you have a lot of, let's just say, cholesterol or whatnot in your body, I mean, you want to protect your system just like you want to protect your body. You could have basically, the system could have a heart attack. So you don't want it to do that.
Interesting. So I never thought of it from that respect. So yeah, so it's in the system. It causes heat transfer to be less efficient. Plus it causes damage to coils, whether it's in the air handling unit or, not damage, but it clogs them. It makes them less efficient that way.
Exactly.
I was thinking of like back in the centrifugal chiller days when I used to sell those, cleaning those tubes is a major endeavor. It's not cheap. And, if you clog the tubes, which are usually grooved inside, so there's a lot of places for the rust and the dirt or whatever to get entrapped, and to clean those is a big endeavor. And it's a huge degrade in efficiency for chillers. It's centrifugal chillers or any type of chillers that has a heat exchanger, especially have like a plate and frame heat exchanger.
Exactly, yeah, there's a lot of tiny crevices for anything.
So maintenance, efficiency, longevity, all these things are super important when we're trying to keep our chill water or hot water loops clean. So one more question about the air. So how does air get into a sealed system, like typically? Does it come in through the makeup water? If you have, let's say a chill water loop, for example, that's not open like a cooling tower, right? So.
Okay, yeah, I mean, there are quite a few ways of air to simply get into the system. One of them is maintenance. You could have, whenever you're doing maintenance, you obviously open the system in that case. So there's a lot of air that just naturally goes in there. Makeup water actually has roughly about 10% of just dissolved air. And dissolved air is its own tricky little animal, but it is very, very, very tiny air bubbles that we physically just cannot see. We've got a little demo going on here, and you can actually see the air bubbles in it. But the dissolved air, they are micro bubbles. Basically take a bubble and divide it by 57,000 times, and that's what a dissolved air bubble is. They're so tiny, but they displace evenly. So you don't actually know that they're there But in reality, I mean, we see it, and we do get dissolved air out of the system as well too. So, and there's obviously, I mean, like I mentioned, underground leaks or whatnot, or just leaks in general, gaskets failing, stuff like that. I mean, air is very easy to get in there, even though it's a closed loop system, like you said, or obviously an open loop is obvious, but.
Right. So you were talking earlier, there's 3 types of air in a system?
Yep.
Entrained, which we just talked about, I believe.
Yep, a little bit.
What are the other 2? Or you can go through all 3, that'd be great.
Sure. So entrained air, it's a tiny bubble. So if you guys can see behind me, the bubbles that are moving around, that's entrained air. It's air that is basically within the flow path. I used to live in Michigan when I was growing up, and we had in-floor heating. My room was in the basement, and you could hear whenever the zone above me would call, because we had a drop ceiling, but you could hear, and I'm just kind of use my hand, but you could hear the water going back and forth and back and forth. And when I was a kid, I thought, oh, that's really cool. The heat is on, because you live in Michigan, the heat needs to be on basically. But you could hear the water. You shouldn't be able to hear water moving through the system.
So when you hear water, that means there's air in it. I never really put those 2 together, but okay.
Yeah, you can hear it going around the bends and whatnot. And obviously, there's a bunch of U-bends everywhere in in-floor heating. You can also it's a weight difference as well, too. You wouldn't think of it, but you can actually, the house was brand new, but you could still hear the floors creaking and whatnot. So that was a really easy indicator of what entrained air is. For technicians and whatnot, they can see it with pressure gauges. They like to bounce. They bounce all over the place. That's entrained air basically hitting that pressure gauge, and it's there is what it's doing. So the other form of air is called entrapped air or free air. That's air that's at a high point in the system. So any point that goes, honestly, it goes up and it goes down, that is a high point within the system.
So let me just make sure I understand, because you were explaining this earlier. So I always think of the high point as, if it's a 10-story building, the highest point's on the 10th story. So what you're saying is, on story 5, if you have a up and down scenario, you can still get entrapped air.
Correct. Okay. Yeah. I mean, if you have, you don't do this, but if you had a wave of pipes, so to speak, each top crest of that wave would be a high point. The entrained air, the entrapped air, and we talked about dissolved air in the beginning there. Those are your 3 forms of air, and we'll get about 100% of the entrained air, 100% of the entrapped air, and 99.6% of the dissolved air, which you say, why can't I get the other 0.4? And it turns into a math equation is what it is. Unless we're actually boiling that water, that's where you get the 100% air. But we don't boil water in a hydronic system because it turns into steam.
Okay, so tell us about the 3 different types of Spirotherm products you typically see for air and dirt. Okay,
so we do have an air-only product, which is kind of in its own name. It's an air-only separator. You can do that a lot in like new construction, an opportunity like that, because we're not so much focused on the dirt in a new construction opportunity, unless there's something physically in the pipes. I mean, we've seen wrenches, 2x4s, face masks. I won't get into the nitty gritty. I've heard underwear. Underwear is always a funny one.
That's interesting. Yeah.
So obviously with an air-only unit, we're only focused on the air part of it. So that's all that we want to get out of it. Now, a dirt-only unit would be a great opportunity for like an open loop system. Cooling tower, exactly.
Right.
Like a dirt-only unit is great for that application. You can have, historically, before there was a combination unit, you would have an air-only unit, and you would have a dirt-only unit, and you'd have 2 separate pieces. So go figure, what they did was they combined them together. Makes sense. So now you have an opportunity for an air and dirt separator all built into one product. So
is that what you sell most of on a closed loop, like a chill water?
It is the most common. It's not so much, you're not actually paying for twice the unit, so to speak. It's roughly about a 20% cost increase to go from one to the other, because it's just really a matter of expanding the material. There's not really that much more labor involved in it. So the cost savings to have both technologies is easily there. So
sounds like a no-brainer.
Exactly.
Thank you, Jamie.
Thanks,
Appreciate you.